Good morning, everyone. All right, yep. So, like he said, my name is Ashley Yvonne Howard, and I'm a solutions engineer at Panther. So today I will be discussing securing the software supply chain with detection as code. But before I get started, I want to tell you a little bit about myself, and then we'll get into the fun stuff. So I've got my bachelor's in German from the University of Michigan. Go Blue! And then I decided I wanted to expand my focus to one we all know and love, cybersecurity. This led me to complete my master's in cybersecurity from the University of Denver. Throughout my career, I've covered a multitude of spaces in SIM, breach and attack simulation, and MDR. And I've held positions from technical support to customer success to sales engineering. After my experience at Logarithm, Attack IQ, and Expel, I've come full circle back to the SIM space at Panther, and I'm excited to tell you more about our SIM today. So on the agenda today, we are going to discuss what software supply chain is, just to level set, software supply chain attacks in action, choosing what to monitor, critical AWS log source types, how Panther helps, and key benefits of Panther. So without further ado, let's jump in. So like I said, I want to level set so we're all on the same page. In cybersecurity, the software supply chain refers to the series of processes and resources involved in developing, maintaining, and distributing software products. Basically, you can think of the software supply chain as something that encompasses the code, libraries, tools, and services used to create software, as well as the developers and infrastructure involved. So, why does it matter? A software supply chain attack targets vulnerabilities within these interconnected components, potentially compromising the software at any stage from development to delivery. Of course, this can lead to widespread impacts as malicious code or vulnerabilities are propagated through trusted software updates or dependencies. This kind of threat is something that is becoming critically important for security today. So let's dive into some examples just so you can really understand the impact of this kind of attack. So by a show of hands, how many of you are familiar with Lazarus? All right, a couple of you, cool. So here's the deal. This group was specifically targeting developers, and they did it in a sneaky way through social engineering. So they use LinkedIn and Slack to send enticing links to open source projects that they knew these developers might be interested in. So here's where things get interesting. Of course, these links weren't innocent invitations. Clicking on them led to the execution of code on that developer's local system. And then that code contained malicious dependencies. So when the developer ran the code, their system got compromised. But that's not all. That developer may have had access to a GitHub repository, so that could also be compromised as a result. And this tactic is continuing to gain momentum, and it's not hard to see why. By injecting malicious code into widely known or widely used projects, attackers can wreak havoc downstream. So they can access intellectual property of those organizations, creating more chaos and significant damage. And another scary part is they can uncover access tokens and other critical infrastructure. It's all part of their game plan. So another example that has been making waves is Lapsus. How many of you have heard of Lapsus? All right. So you might be surprised to learn that attacks are no longer exclusive to adults or sophisticated attack techniques. This is actually a group of teens, and they weren't just messing around. They were specifically targeting platforms like Okta and other cloud infrastructure, as well as code repositories. And why is that? To get their hands on valuable information or potentially compromise other users downstream. But let's dive a little bit deeper into their tactics. So they had a few tricks up their sleeves. They start by gaining initial access through various means, such as deploying password and token stealers, purchasing credentials and session tokens from underground forums, and even paying off employees to get access to these organizations, to those credentials and MFA approvals. And lastly, they were also searching public code repositories for exposed credentials. I mean, these kids were relentless. It reminds me of that saying, kids say the darndest things, but in this case, they do the darndest things, but let's not kid ourselves, pun intended. This is no joke. Lapsus is a real group that has been making headlines. So now I would like to walk you through what a contemporary supply chain threat might entail. Over the next few slides, I'm going to refer to the Lockheed Martin kill chain, but you'll see all of the attack techniques are also mapped to MITRE. So part one of the attack is an Okta admin compromise. It all starts with the reconnaissance phase where the attacker obtains leaked credentials. With these credentials in hand, the weaponization phase begins, utilizing a tool like Osprey to prepare for the attack. And for those that don't know, that is a password spraying tool that attackers use to get credentials. So they were able to brute force their way into the system to gain access, and then once in, they moved into the exploitation phase, which is where we have that compromised Okta admin account. And of course, they don't stop there. In the installation phase, the attacker generates an API key, and that gives them further control. They'll go on to create their own user, escalate that user's privileges, and solidify their foothold. And then, drum roll please, they pivot over into a cloud or SaaS or a code repository. So let's imagine that this code repository is on GitHub, and that's where the attacker moves next. So it all starts with that previously generated API key, and they gain access to the repository, and of course they don't stop there. Why would they? So with that, the attacker has the ability to read, modify, and push malicious code into the repository, and that sets the stage for deeper infiltration. The attacker then creates a new user within GitHub, and that's to ensure persistent access. Then they escalate that user's privileges, gaining full control over the repository and its settings. So finally, that same attacker can download the entire repository, and in that repository there can be valuable intellectual property, source code of course, and sensitive credentials. Let's say one of those sensitive credentials is an AWS IAM key. So that means the attacker could then pivot over into the organization's AWS environment. So with that key obtained by the GitHub repository, the attacker could create backdoor access by adding new IAM users with similar permissions and deploy malicious scripts on EC2 instances. They could also set up an SQS queue to issue commands and exfiltrate data. They could make private GitHub repositories public and expose more sensitive code that way. And they could also download large amounts of sensitive data from S3 buckets and other storage services, including intellectual property and customer data. There's all sorts of things that the attacker could do. This is just one example, but let's say to cover their tracks, they could delete CloudTrail logs and other audit trails. They could even delete S3 buckets or EC2 instances. I mean, that's really scary, right? Customers are prone to these types of attacks if they aren't monitoring things like GitHub or CloudTrail. And maybe they're not monitoring those things due to cost, technical constraints, or maybe they just don't see it as necessary. But I feel like I've painted a pretty clear picture as to why it is necessary. I mean, it creates major blind spots in their defenses, leaving them vulnerable to crazy attacks like this. So, and these are multi-vector attacks, of course. So, having having the right tools in place to detect and respond to these types of threats is very important. And over the next few slides, I will go over why Panther is a tool that can help you cover these kinds of attacks. So, as I said in the beginning, Panther is a SIEM. We are a cloud-native SIEM. We're built on AWS. And when I started at Panther, one thing I noticed that was pretty interesting is that the top data sources are very different from that of legacy SIEMs. For example, customers I worked with at Logarithm were heavily focused on collecting things like firewall and networking logs. Overall, the focus was on corporate security realm. And those are the data sources I was used to seeing. So when I came to Panther, I noticed customers are looking to cover data sources focused on AWS, the dev area such as GitHub, custom application logs, authentication logs from Okta. In other words, our focus is on cloud-originated data. This is Panther's bread and butter, our ikigai, our Lebensweg. It's what we do. And with custom application logs being in the top 5, this indicates customers have a lot of flexibility to bring in that data and write detections against it. On top of that, it's really easy to do. So having all of this information tells me a really interesting story that companies are tech companies, whether they like it or not. I suspect more organizations are going to be utilizing log sources like this, or data sources like this, and because of that, SIEM has to be equipped to handle this evolution. So now I want to talk about the critical AWS log source types. Individually, each log can provide valuable insights, but it's only when you enable logging across your entire environment that you can truly understand the complete narrative of your AWS infrastructure. When determining the most important logs to collect, there are 3 overarching categories to consider. So first we have platform-wide activity. So CloudTrail, for instance, monitors all API calls made within the AWS account, offering a comprehensive audit trail of actions taken by users, applications, and AWS services. This not only helps track changes and investigate security incidents, but also ensures compliance with regulatory requirements. Then we have services. So from S3 to VPC logs and AWS Guard Duty, these logs capture system-level activity within specific AWS services. They play a crucial role in detecting unauthorized access, data breaches, network traffic anomalies, and other suspicious activities. And then finally, we have host-based logs. Collecting host-based logs from EC2 instances provides insights into application-level activity, system performance, and security events. These logs help identify issues, troubleshoot errors, and monitor for unauthorized access, as well as maintain compliance, ensuring the security and operational efficiency of your AWS environment. So it's important to follow a trend of starting broad and drilling down into specific services and systems where activity could be occurring. And to, one second, oops. Sorry, 1 second. This went back one. So yeah, compromising any of these data sources could lead to things like data breaches, financial losses, and reputational damage. So similar to that previous example I showed you, the kill chain one, if someone assumes a role and exfiltrates data from an S3 bucket, CloudTrail logs the role assumption event, while the S3 server access logs record the request to access the bucket. But what else did they do in your environment? Perhaps they moved into an application running on EC2, leaving traces in application logs. So when you aggregate all of your AWS data, you gain a comprehensive view of your cloud environment. This is where tools like Panther shine, making it easy to collect, analyze, and visualize AWS logs to provide actionable insights and enhance security posture. So next, we will dive into Panther's architecture, as you saw, so I can further explain this. So one of our core strengths lies in our extensive coverage and ease of onboarding security-focused log sources, some of which may not be top of mind, like the ones we talked about today so far. And don't forget, we can also handle your custom application logs. We meticulously collect and analyze these logs, providing deep insights into platform-wide activities, service-level events, and host-based activities. Upon ingestion, we deploy our detection logic, employing a revolutionary concept called detection as code. This means we treat our detections as a piece of software, allowing for version control and integration with CI/CD pipelines. With detection as code, you can send detections to any alert destination whether it be a ticketing system, SOAR platform, even Splunk, as well as custom webhook options. Really, this is offering unparalleled flexibility. And utilizing our security data lake powered by Snowflake, we provide 1 year of hot searchable storage, ensuring accessibility and agility in data retrieval and analysis. Explaining further how Panther helps, I'll cover some of our key differentiators. So first, we have clean data. Panther excels at parsing and normalizing petabytes of security data within the security data lake. Again, that's powered by Snowflake. By converting unstructured logs into a structured format, we ensure consistency and accuracy in data representation. This enables easier analysis, correlation, and detection of security events, which is going to reduce the likelihood of false positives. Improved data quality and consistency empowers practitioners to effectively detect and respond to security threats, minimizing alert fatigue, response times, and enhancing overall security posture. And then the second one is that we are cloud native. Like I said, we're built on AWS. So because we're born in the cloud, we offer real-time detection at a petabyte scale. This enables our customers to respond to alerts more efficiently. And our serverless architecture ensures high performance without the operational maintenance overhead. And with zero ops, you can focus on high-value security tactics while our security data lake offers flexible ingest pipelines and cost-effective storage. And then we have detection as code. Like I mentioned, this is our unique approach that transforms security operations with flexible, scalable detections aligned to CI/CD engineering principles. These are just some of our key benefits, and Panther is a leading solution for modern security operations, empowering organizations to effectively detect, investigate, and respond to threats in today's dynamic threat landscape. To highlight the perks of Panther further, one of our customers, Asana, reflects on the benefits of detection as code, stating how nice it is to be able to create custom detections for their specific needs and manage them as code. Other advantages include alert fidelity, total cost of ownership, and efficiency. Ultimately, security teams can focus on high-value tasks and strategic initiatives, and allowing organizations to optimize resource utilization and maximize efficiency across security operations. And we have happy customers in various verticals, along with our investors here that believe in our product and unique approach to the market. So I would love if you all stop by our booth. We're at 309. We'd love to give a demo, talk to you more about your needs and how we can help. And I will end on something very cheesy. So whether it's Mazen Blue, Blue Teaming, or Panther Blue, go blue. Thank you.